Hello viewers, you're welcome back to my channel. In this particular video, I'm going to review 5 Utme past questions in chemistry. So do well to stick around and watch this video lesson till the end. So our first question on the board reads, the subatomic particles located in the nucleus of an atom are option A says proton and electron, B says neutron and proton, C neutron and electron, and D proton and ions. Now before answering this question, it is important we ask ourselves, what's an atom? Now, an atom is said to be the smallest and indivisible part of an element. Now, what does that mean? It's very simple. Just take a piece of paper, cut that piece of paper till you get to a particular point where you can no longer cut that smallest or tiny piece. That smallest piece is what referred to as an atom. So, the smallest part of an element, when you try to divide it, is what is best referred to as an atom. So, initially, there was a chemist called John Dalton. He believed that atoms cannot be divided further, but later experiments proved that you can divide an atom to give us 3 subatomic particles. When I say subatomic, they make up the atom. And what are those 3 subatomic particles? We call them proton, electron, and neutron. So remember, pen, P-E-N, P-E-N, where P is for proton, E is for electron, and then N is for neutron. So within an atom, we can find 3 subatomic particles called proton, electron, and neutron. But mind you, there are specific portions within an atom where you can find these particles. Now this is an easier illustration of an atom. For an atom, we have a positive centered portion. That positive centered portion is called the nucleus. The nucleus. And within this nucleus, we'll find 2 out of these 3 subatomic particles. And what are those 2 things? We'll find the proton within this nucleus, and then we'll find the neutron within the nucleus. So within the nucleus, we can find 2 subatomic particles, which are proton and neutron. Then there's a part called an orbit. What's an orbit? An orbit is that part surrounding the nucleus where we are most likely going to find an electron. So within the orbit, we'll find what we call electrons, which are negatively charged. So we have protons, which are positively charged, neutrons, which have no charge. These 2 are found within the nucleus. Then in the orbit, that's where we can find the electrons, which are negatively charged. So we can now answer this first question, which says, which subatomic particles are located in the nucleus? In the nucleus, we have proton and neutron. So that makes the answer to this question to become option B. So the 2 subatomic particles that are located within the nucleus are proton and neutron, while the electrons are located within the orbit. So ions, what are ions? Ions are atoms that are charged. So for example, we can have sodium atom as Na. So when sodium atom becomes charged, that's Na+, this is no longer called an atom, but it's now called sodium ion because it is charged. Or we can have chlorine ion or chlorine atom as Cl rather, but when it becomes charged, it becomes Cl-. So this is called chlorine atom, no charge. When it is charged, it becomes chlorine or chloride ion. So moving on, our second question says, how many neutrons are present in an atom with a mass number of 37 and then the atomic number of 17? Remember, the word here says respectively. So in this particular question, the mass number is 37 and the atomic number is 17. So we are going to ask ourselves, what is mass number? Now, mass number is simply the total number of protons and neutrons that are present in the nucleus of the atom. Remember, we have the nucleus of the atom. In this nucleus, we are going to find protons and neutrons. The total number of protons and neutrons that are present within this nucleus is what referred to as mass number. So that means that the proton number, and you should know that the proton number is the same thing as the atomic number. So the proton number plus the atomic number, or rather the atomic number, plus the number of neutrons, that the neutron number, will give us the mass number. So we know that the mass number, that this mass number is made up of the total number of protons and neutrons present in the nucleus of an atom. So that means that your proton number, which is the same thing as the atomic number, because if an element has 2 protons, it also means that the atomic number of that particular atom or that element is 2. If the element has a proton number of 14, that means that the atomic number is also 14, because the atomic number is the number of protons that is present in the nucleus of the atom. So atomic number or the proton number plus the neutron number is equal to the mass number. Now in this question, we are told to calculate the number of neutrons present in this atom. Now the atomic number for this atom is 17. So we have 17 plus the neutron number, which we are looking for, let's take that as n, is equal to the mass number, which is 37. So in mass, you simply do what you call, you collect like terms. So we have 17 plus n is equal to 37. When we take 17 to this other side, we have that n is equal to 37 minus 17, and that will give us 20. So it means that in this atom, there are 20 neutrons present in that atom. So the answer to this question is option B, 20 neutrons. So if you want to understand this part of atomic structure, you can refer back to this particular video on your screen so that you can watch where I've explained the entire concept of atomic structure. Now, our third question on the board reads, zinc is a dash. Zinc oxide rather is a. Now, what's the most important thing here? We have basic oxide, amphoteric oxide, acidic oxide, neutral oxide, and then reactive oxide. So before answering this question, we have to ask ourselves, what are oxides? Now, what's the oxide? Oxides are simply formed when oxygen reacts with other elements. For example, if we have sodium and sodium reacts with oxygen to form a compound which we call Na2O, we are going to call this compound sodium oxide. So whenever oxygen reacts with an element, the compound formed is called an oxide. It's just like if chlorine reacts with other elements, we call it chloride. If sulfur reacts with other elements, we call it sulfide. If carbon reacts with other elements, we call it carbide. So also if oxygen reacts with other elements, they are called oxide. Now, we have various types of oxide. We have what we call the basic oxide. Now, what are basic oxide? Basic oxides are formed when oxygen reacts with metals. For example, when oxygen reacts with a metal, in this case sodium, we are going to form a basic oxide. So this is a basic oxide. Basic oxide. So there are two reasons why we call them basic oxide. They are called basic oxide. Number one, because they are formed from metals. Then secondly, whenever they dissolve in water, they will dissolve in water to give us a base. And we know base from acid and bases. So that's why they are called basic oxide. So next we have what we call amphoteric. But before we answer amphoteric, we are going to answer acidic oxide. Now, what are acidic oxide? Acidic oxides are oxide of non-metals. So, for example, we have carbon, let's say plus oxygen. This will give us CO2. So this one is called an acidic oxide. Now, why is it called an acidic oxide? It's called an acidic oxide because it is formed when oxygen reacts with a non-metal, in this case carbon. And secondly, they will dissolve in water to give us acid, just like basic oxide will dissolve in water to give us bases. Next, we have what we call amphoteric oxide. Now, what amphoteric oxide? Amphoteric oxide are oxide of elements that behave as both acid and base. You see this word ampho. Ampho means dual, like they have the ability to have two properties, just like we have what we call amphibians in biology, because they have the ability to live on both land and in water. So for amphoteric oxide, they have the ability to exhibit two properties. They exhibit properties of acid and they exhibit properties of base. So that's why they are called amphoteric oxide. And for your exam, know that we have 4 basic amphoteric oxide. And how will you easily remember? Remember with this acronym called ZILAT. ZILAT. Where Z stands for zinc oxide. Zinc oxide. This area stands for lead oxide. This A stands for aluminium oxide. And then the T we have here stands for tin oxide. So we can therefore answer this particular question, which is zinc oxide is what? Now from our acronym, we now know that zinc oxide is an amphoteric oxide. So answer to this particular question becomes option C. Why is it an amphoteric oxide? Because it has the ability to behave like an acid and also as a base. Also, we have what we call neutral oxide. What are neutral oxide? They are neutral because they are neither acidic nor basic. A good example of neutral oxide, we have carbon monoxide or carbon 2 oxide. We have dinitrogen 1 oxide. These guys are neutral oxide because they are neither acidic, neither are they basic. Also, one other one that is not shown on the board is what we call peroxide. What are peroxide? Peroxide are simply oxide that contains an extra amount of oxygen, like they just have an extra amount of oxygen to their compound. For example, this is Na2, which is sodium oxide. If there's an extra oxygen, let's say Na2O2, this is no longer sodium oxide like this guy. We now call it sodium peroxide. Just like we have H2O to be water, this is an oxide. But when it becomes H2O2, because there's an extra quantity of oxygen, we call this compound hydrogen peroxide. So to question 1, our answer is B. To question 2, our answer is B. And also to question 3, our answer is B. Moving on, the fourth question on the board reads, the oxidation state of chlorine in potassium chlorate is. Now we have various options for this particular question. So before answering this question, it is important to write the chemical formula for that compound, which is potassium chlorate, and it is KClO3. So now this particular question is on oxidation number, calculation of oxidation number, and there are various rules for calculating oxidation number. The one that pertains to this question is this. The rule says that the sum of the oxidation number of the individual elements that makes up a compound that is not charged is equal to 0. If you look at this compound, there is no charge attached to this compound. So the rule says that if you add up the oxidation number of the individual elements, let's say the oxidation number of potassium plus the oxidation number of chlorine plus the oxidation number of oxygen, mind you, we have 3 atoms of oxygen, so that becomes 3O. It will be equal to 0. 0 because this compound is not charged. So for potassium is a group 1 element, and group 1 element have the oxidation number of +1. So this will become +1 plus, in this question, we are looking for the oxidation number of chlorine. So we don't know what chlorine is, Cl, plus 3 times the oxidation number of oxygen. There's a rule also that says that the oxidation number of oxygen in all compounds is -2, except in peroxide. If you go back to question 3, I talked about peroxide. This compound is not a peroxide. So the rule says that the oxidation number of oxygen in all compounds is -2, except in peroxide where it is -1. Since this compound is not a peroxide, that means that the oxidation number of oxygen will be -2 is equal to 0. Now when we solve this one, so we have this as 1 plus oxidation number of chlorine plus -6 is equal to 0. So this will become 1 plus Cl minus 6, because plus times minus will give us minus, equal to 0. So when we collect like terms, we take the number to the other side. So that as chlorine is equal to 6. When -6 comes this way, it comes +6. When +1 comes, it will come -1. So therefore, the number of chlorine is +5, +5. So the answer to this particular question is option D, which is +5. Moving on, our fifth and last question is, a small quantity of solid ammonium chloride, NH4Cl, was heated gently in a test tube. The solid gradually disappears to provide 2 gases. Later, a white cloudy deposit was observed on the cooler part of the test tube. The ammonium chloride is said to have undergone which of these separation techniques? Now, these are various separation techniques. So what I'm going to do is that I'm going to analyze every part of this question till we arrive at our final answer. Now, the first part of the question says there was a small quantity of solid ammonium chloride. So we have solid ammonium chloride, that's NH4Cl, in the solid state. So when heated, this gas gradually disappears to provide 2 gases. Now, what happens when you heat solid ammonium chloride? when this solid rather is heated, it will decompose to give us ammonia gas, that's NH3 in the gaseous state, and hydrogen chloride gas, HCl, also in the gaseous state. Now later, a white cloudy deposit was observed. So what was this white cloudy deposit? This deposit was observed on the cooler part. So when we cool these two gases, they will react or they will recombine to give us ammonium chloride back again. So in the solid state. So on cooling, these two gases will recombine or will react to give us ammonium chloride in the solid state. This is what will now appear as a white cloudy deposit. So what happened during this entire process is that when you heat solid ammonium chloride, on heating it will decompose to give us ammonia gas and hydrogen chloride gas. Then on cooling, these two gases will react or will recombine to give us solid ammonium chloride. So now what happened at the initial part of this reaction is that this solid substance on heating turned to gas, and this process is what is known as sublimation. So what is sublimation? Sublimation is the process whereby a solid material turned into the gaseous state without passing through the liquid state. Because if you take a solid, let's say ice, and you heat it, it must turn to liquid. Then when you heat it further, it will then turn to a gas. But in this case, the substance migrates or is converted from the solid state to the gaseous state without going through the liquid state. One good example is the naphthalene or the camphor balls. Most times when you buy the camphor balls, you place them at various spots in your house. You observe that after some time you start perceiving the fragrance of that camphor. What has happened is that the solid camphor that you kept at various spots in your house has turned to gaseous form that you can perceive. Now we know that the answer to this particular question is sublimation, because this substance turned from the solid state to the gaseous state without going through the liquid state. But let's analyze the other options. What's distillation? Distillation is simply a separation technique which is used to separate miscible liquid with different boiling points. Let's say we have two liquid A and B, and they can mix with each other. And let's say liquid A has a temperature of 25 and liquid B has a temperature of 70. When you heat, the one with the lower boiling point evaporates and is lost, leaving behind the one with the higher boiling point. So that's distillation. For evaporation, we used to separate a soluble solute from a solvent, let's say salt in water. What you do during that technique is that you heat. On heating, the solvent is lost, leaving behind the solute. So in the case of salt water or salt solution, the water is lost, leaving behind the salt. So that's evaporation, or we can also call it evaporation to dryness. Then we have what we call filtration. What's filtration? Filtration is a separation technique used to separate insoluble solute from the solvent. Let's say sand particles in water. Sand will not dissolve in water. So when you pass that mixture through a filter paper, the sand is kept on the filter paper, then the water passes through the filter paper. And in chemistry, whatever is left on top of the filter paper is called a residue. So in that case, sand becomes the residue. Then what goes through the filter paper is called the filtrate. So in that case, water becomes our filtrate. Then we have decomposition. What makes this answer not decomposition is that in decomposition, let's say we have a substance like calcium triazocarbonate 4. When this substance is heated, it decomposes to give us calcium oxide and carbon 4 oxide. So in this case, these two substances cannot recombine to give us this. So, and also this is in the solid state, this also is in the solid state, but this is in the gaseous state. But in sublimation, that solid substance turns directly to gas without going through the liquid state. So this is a case of decomposition, but this is a case of sublimation, because this solid is moving to gaseous state without going through the liquid state. Dear viewers, I hope you enjoyed this video lesson and you learned something from this particular video lesson. Don't forget to like and share this video, and also do it to subscribe to this channel if you haven't done that. Till you get to see my next video, do have a wonderful time.